What is RISC? The full form of RISC is Reduced Instruction Set Computer. RISC is a microprocessor that is designed to perform a smaller number of computer instructions so that it can operate at a higher speed. Second, it is a type of computer architecture that utilizes a smaller number of simple instructions that can be executed quickly, as opposed to a large number of computer instructions in CISC. CISC is Complex Instruction Set Computer Architecture. This allows for faster performance and a more efficient use of memory. Third, RISC reduces the cycles per instructions at a cost of numbers of instructions per program. Fourth, this allows for the faster performance and a more efficient use of memory. RISC architecture is commonly used in mobiles, devices, and embedded systems. Fifth, examples of RISC are MIPS, PowerPC, Atmel AVR, microchip PIC processors, ARM processors, and RISC-V. Characteristics of RISC: it has simpler instructions and thus simple instruction decoding. Second, more general purpose registers. Third, the instruction takes one clock cycle in order to get executed. Fourth, the instruction comes under the size of a single word. Fifth, pipeline can easily be achieved. Sixth, few data types. Seventh, simpler addressing modes.
I am here to share information about what is CISC. CISC stands for a complex instruction set computer. It comprises a complex instruction set. It incorporates a variable length instruction format. Instructions that require register operands can take only 2 bytes. The task of a compiler is to generate a sequence of machine instructions for each high-level language statement. The task is simplified if there are machine instructions that implement the statements directly. The essential goal of a CISC architecture is to attempt to support a single machine instruction for each statement that is written in a high-level language. For examples, VAX, AMD, Intel x86, System 360. Now we will see the characteristics of a CISC. First one is instructions are complex and thus it has complex instruction decoding. Second one, the instruction may take more than one clock cycle in order to get executed. Third one, the instruction is larger than one word size. Fourth one, lesser general purpose registers since the operations get performed only in the memory. Fifth one, more data types. Sixth one, complex addressing modes.
Now let's summarize RISC and CISC processors by studying the difference between them. Now first of all, the RISC processor is used to perform smaller number of instructions, and as it performs lesser instructions, it works at a higher speed. On the contrary, the CISC processor performs complex instructions which reduces its execution speed and it runs at a slower pace. Most of the RISC processors are based on hardware control unit design, which includes a fixed logic circuits to interrupt instructions and which generate control signals from them, whereas CISC is controlled by microprograms. A large number of registers are used in the RISC processor because it wants to avoid interaction with the memory as much as possible, whereas CISC uses very few registers. Normally, it just has a single set of registers. RISC processors don't have many addressing modes, and whatever addressing modes they are rather very simple. Most of the addressing modes are for register operations and do not refer memory. More number of addressing modes are used in CISC processor as the instruction used there are of different varieties. And lastly, fixed number of operands are used in RISC processor, whereas the number of operands used in CISC are variable. They vary according to the use and purpose of the CISC processor.
In case of scalar organization, integer register file and floating point register file are interconnected to memory via single pipeline function unit, whereas in case of superscalar organization, integer register file and floating point register file are interconnected to memory via multiple pipeline function unit. So in order to execute an instruction, there are two types or two ways of doing it. First is with the help of non-pipeline execution and other one is with the help of pipeline execution. In non-pipeline execution, the execution of instruction take place in a sequence one after the other. A new instruction get executed only if the previous instruction is successfully executed. The process requires multiple clock cycles and hence overall efficiency is very low. Whereas in case of pipeline execution, multiple instructions are executed at a particular time, that is, multiple instructions are overlapping execution. Many instructions get executed at the same time and hence the process requires fewer clock cycles as compared to that in non-pipeline architecture. The style of executing the instruction is highly efficient and hence most widely used for execution of instructions. Instruction pipelining is a technique that implements a form of parallelism called as instruction level parallelism within a single processor. A pipeline processor does not wait until the previous instruction is successfully executed.
We are about going to see a four-phase pipeline architecture, namely as instruction phase, instruction decode, instruction execute, and write back instructions. In this architecture, the hardware is divided into four functional parts, each of which performs a certain purpose in order to create this structure. As we can see in this diagram, the program's instructions run simultaneously through pipeline execution. Stage 1, Stage 2, Stage 3, and Stage 4. And this is how a pipeline featuring four stage instruction works.